So first thing we're going to do is we're going to take a look at exactly how to find the missing side. So for those of you guys who I happen to teach in class, okay, I've been telling you guys to write SOHCAHTOA in a very specific way. So for anyone that hasn't seen me write this in my class, the way I teach my students to do it is to write it like this. So I write SOHCAH and TOA like this because I think that this much better gives you an better idea of what your trig ratios are going to look like, what side is going to be on top, and what's going to be on the bottom. Okay, so if you learn to write it like this, I think that'll kind of clear up some of those misconceptions of, oh, how do I know if I'm dividing? How do I know if I'm going to be multiplying instead? Okay, just to run through a couple of these, make sure we're feeling pretty good about ourselves. We'll go through a couple of these and we'll see how we do. So for the first one here, again, starting off with SOHCAHTOA, after we do that, we want to start off by looking at what we call our reference angle. So in this case, it's going to be 27 degrees. So because we're looking at the opposite side here, so this opposite side is going to be what x is being represented by right now. So that's my opposite side. The next one I like to label is then my hypotenuse, which is directly across from that right angle. And then last but not least is going to be the remaining side, which is the adjacent side. Okay, so like I said, we want to start off with the opposite side. It's not only going to be on trigonometry; it's going to be on finding angles using trigonometry or using SOHCAHTOA, and we're also going to be doing volumes of spheres and cones as well. Okay, hope that helps out. All right. So taking a look at my three sides, basically at this point, we're going to figure out which two sides we actually need. So since we're trying to find the opposite side, okay, we need the opposite. I don't know what the hypotenuse is, so I'm going to skip that, and I'm going to move over to the adjacent side. Okay, so looking at SOHCAHTOA, we now need something that has both the opposite and the adjacent. Okay, and that's only going to be the tangent ratio. All right, so starting with our tangent ratio, we're going to start off by just writing it down first. So tangent of some angle, let's call it theta. So this here, it looks like a little I. This is pronounced theta. It's really just a variable. Okay, so this is just basically an unknown angle. Okay, so some angle is equal to the opposite side over the adjacent side. Okay, so I like to do that to start things off, just to make sure I haven't written anything down incorrectly here. Okay. Sorry, that's Mr. Waits calling me to make sure that we're all set to go here. Um, all right, sorry about that. So what we're going to do from here is we're going to replace this unknown angle because I actually know what that angle is. We're going to replace it with that 27 degrees. Okay, so tan 27 is equal to opposite, which is x, divided by my adjacent side, which is 10. Okay. So there's going to be two scenarios. All right. So some of you guys might be saying, how do I know if I multiply? How do I know if I divide? All right. So I'm going to compare and contrast here. So I'm just going to write out what would happen if x was on the bottom. All right. So you don't need to write this part on the side if you don't want. But let's say we had something like this. All right. So how do you know which one is which? Well, in this case, because we're trying to make x the subject here on the left-hand side, or my left-hand equation here, x is being divided by 10. So to undo that, we're going to multiply both sides by 10. So I get rid of these. So the 10s will cancel or factor out essentially. And because I multiplied by 10 on the right-hand side, I'm also going to multiply by 10 on the left-hand side. So what that leaves me with is 10 times the tangent of 27, and that's going to equal to x. So here on my calculator, I'm just going to go ahead and punch in 10 times tangent of 27, and I get about 5.095, and maybe I'll hold it up to my camera here so you guys can see. So 5.095, and because it says round to the nearest tenth, it's going to end up being 5.1. Okay. And since we don't have any units, I'm just going to write units down. So 5.1 units. So x is equal to 5.1 units. Okay. Sorry, Mr. Waits is asking me about the link to my meet here. So give me a second here. Sorry, it's kind of we're all over the place tonight. So I apologize. There we go. Okay, so hopefully we can move on to what would happen if it was the other situation. Okay, so if we're looking at the other situation, so I'm just going to forget about this stuff that we just did here on the right hand side. I'm going to look at this one here. So what happens if x is on the bottom? Okay, essentially, if x or your variable is on the bottom, all we're going to do is we're just going to replace the x with whatever we see here. Okay. So the reason why we're allowed to do that is because tan 27, if I were to punch in tan 27, my calculator, we end up getting 0.5095, as you can hopefully see there. Tan 27 is a number. Okay. So let's say, for example, if we had 4 is equal to 10 over x, basically, I'm just swapping this 4 with this x. Okay. And I just get x is equal to 10 over 4 instead. Okay, and that's perfectly valid. Again, there's a reason why we're able to do that. It's just because of the way that fractions are working. We're making x the subject first, by multiplying both sides by x. And again, there's I think 2 or 3 steps in between. But just for the sake of being able to figure out that work a little bit faster, perfectly valid for you guys to do. If this is the case, all we need to do is go x is equal to 10 over tan 27. Okay. So this would be a totally different question, right? But in terms of finding out or figuring out, do I multiply both sides by a number or do I divide? What am I doing in this case? So if x is on top, your variable is on top, you multiply by whatever number is on the bottom to both sides. If x is on the bottom, then we just switch the x with whatever is here on the left hand side. Okay, so hopefully that part makes sense. What I'm going to do actually is I'm going to do an example where x is going to be on the bottom. So we can look at the example of, let's go with number 4 here down at the bottom. So let's come down to question number 4. And what we'll be able to see is that x will end up being on the bottom. All right, so with every trig question, I always start off by writing SOHCAHTOA, just like so. SOHCAHTOA. And it's going to show up just like that. And we're going to label our sides. So here's my reference angle where I'm looking at the rest of the triangle from. I'm going to label my opposite side first, my hypotenuse, and finally my adjacent side. Okay. So because we need the opposite side and we're trying to find out the hypotenuse, that means we're going to be using the sine ratio. Okay, so that's how I essentially structure my process. That's my problem solving methodology behind all of this. And from here, we're going to start off by saying, well, sine of theta, sine of some angle, is equal to opposite over hypotenuse. And then we're going to fill it in with everything that we know. So sine of 46 degrees is equal to my opposite side, which is 8 divided by x. So you can see here in this case, x is on the bottom. Okay, so we can go ahead and we can actually switch that with that sine of 46. Now, I saw Louis had the question of why do you multiply by 10? For that previous question, I just saw that, sorry. So for this previous question, we multiply by 10 because we're trying to make x the subject up here. Okay, so if we're dividing x by 10, to undo that, we have to multiply by 10. All right, so hopefully that clears that up. So for this, back to this question that we were looking at, because x is on the bottom, I'm just going to switch it with this sine 46. Okay, and that's going to come down over here. So we end up with x, because we swapped it, is equal to 8. And that's going to be divided by sine 46. Okay, so I go into my calculator, 8 divided by sine of 46. That's going to give us x is equal to 11 point, it says 1, 2, so 11.1 units. Okay, so please don't forget your units because you will get you will lose a mark for accuracy if you're not very careful. Okay, so just make sure you guys are aware of that. Okay. For those of you who are curious about the other two, we have x is equal to, I think we said 4.7 units for this one, I believe. 4.7 units. And for this one here on the left-hand side, it was x is equal to 5.4 units. Okay. So hopefully that kind of summarizes what you guys have been working on with Mr. Waits in his sessions. And we're going to move on to finding out angles now. Okay. Do you have any questions up until this point? Will you have to do this without a calculator? No. These parts of the exams will be calculator based, so please don't stress about it. And it's great that you asked this because what I'm going to show you guys next is kind of a quick little precursor to trig history. Okay. So back in the day, okay, even before I was, really in school, people used to use these things to calculate different angles and sides. Okay. So I'm going to look at tan here. So this is what we call a tangent table. And I'm actually going to go back to this question here in a second just to refer to it. So this is basically a table where if you know the angle of something, you can actually find out the ratio of the two sides. Okay, so basically this part right here is what we call the ratio. And the angle is just the angle. Okay, so oddly enough, going back to our first question here, tan 27, well, 27 was our angle. Okay, our angle is 27. So if I go into my calculator and I punch in tan 27, let's see what pops up. Tan 27 is equal to 0.5095. Okay, so I don't know if you guys can see that. Hopefully you can. We get tan 27 is equal to about 0.51 roughly. Okay, so basically we're saying if our angle is 27, okay, and we're going to go back to this table here. If our angle is 27, and I'm going to highlight it, our angle is 27, then our ratio is 0.50 or 0.5095. Okay, which is interesting. And the reason why it's interesting is let's go back to this triangle that we just had. Okay, so this triangle that we just had, we found that x was about 5.1. So if I were to redraw this triangle here, we said this was 5.1. We know this was 10. Okay, and we know we have this angle here. So this would be my opposite side if we're looking from this angle. And this is my adjacent side. And let's think about what happens. If this is some sort of angle A, I can say that tan of angle A is equal to my opposite over my adjacent. So tan of A is equal to 5.1 over 10. Well, tan A, if you put 5.1 over 10, is equal to 0.51. Okay, is that a coincidence? And the answer is no, that's not a coincidence. Okay, so pretty much before we had calculators, we had this cool little chart, okay, that we had to use before calculators were a mainstream thing. All right. And the reason why I talk about it is if we look, for example, at the different ratios here, we have this special one. So this is if if you're doing a higher tier later on, you would actually have to memorize some of these. We can see here that the angle 45 degrees, okay, has a ratio of 1. All right. So what does that mean for us essentially? Essentially, if I were to make a different triangle, and let's say it looks like this, and I'm using that as my angle that we're looking at, and this side is 4 and this side is 4, I know for sure that this angle here is 45 degrees without doing any calculations. How come? Because the opposite side divided by my adjacent side, 4 divided by 4 is equal to 1. So because I know the ratio is 1, then my angle has to be 45 degrees. I can say the same thing about a different triangle. If this was 1,422 centimeters and this side was 1,422 centimeters, then I know for sure that this angle right here is still 45 degrees. All right. So the reason why I bring that up is that is pretty much how we end up measuring or finding out angles if we know two different side lengths. Okay, so we're going to go into our first example and see if we can start to work things out. So I'm going to draw my first little triangle here. So let's start off with this triangle, and I'm going to call this angle. Let's say this angle is I don't want to call that angle anything. I'm going to call that theta. Okay, so this angle here is theta. We're trying to find out that angle. And this will be my right angle here in the corner. And let's say that this is 7 and this side is 12. All right. So according to SOHCAHTOA, let's go ahead, let's write that down first. SOHCAHTOA. I'm going to label my triangle based off of the two sides that I have here. All right. So we have my opposite side, which is going to be down here, my hypotenuse, and finally my adjacent side. Now, again, because I have the hypotenuse and I have my opposite side, I can just ignore the adjacent side. So I need something with opposite and hypotenuse, which is, sine in this case. So I can say that sine theta is equal to opposite over hypotenuse. And we can start to fill this in with things that we know. So sine of theta, I don't know what theta is. Sine of theta is equal to my opposite side, which is 7, divided by my hypotenuse, which is 12. All right, so I'll give you guys a second there to catch up. And draw that picture out. Okay, so everyone's kind of caught up there. And now we want to ask ourselves, okay, we're trying to find theta. This is what we're trying to find, but we have this sign that's in front of it. Now, the cool thing in mathematics is that we can pretty much undo anything that we decide to. We can undo multiplication by dividing. We can undo addition by subtracting. We could undo squaring by square rooting. We can undo this sign. Okay, we can undo this sign basically by doing this. You don't need to write this part down. So to undo the sign, okay, we're basically taking what we call the inverse sign. So if I do this to both to the sign here, so basically what this does is this happens, and I'm left with just theta. Okay, so you don't need to write that down. We typically don't do that on the left-hand side. What we'll end up writing down instead is that we can just say that theta is just equal to the inverse sign of 7 over 12. Okay. So essentially, we can then kind of figure out that this was the ratio, okay, of my two sides. So, and we can just talk about this ratio of two sides. And this is your opposite over your hypotenuse. All right. So we're going to go to our calculators. We're going to put shift. So it's going to look like shift here. Let me see if I can pull up my actual graphing calculator here. So let me share my full screen with you guys. So I'm going to do this. Let me present something else. I'm going to share my entire screen. Let's go ahead and do this. So you guys are going to see my calculator pop up here. All right. So we're going to go shift on your calculator, or second, depending on what kind of calculator you guys have. I don't know what you guys are holding in your hands right now. So shift, I'm gonna hit sine. So it's gonna look like sine to the power of -1, okay, but it's not. It's what we call this inverse sine, okay, or sine inverse. And we're gonna put in 7 over 12 on our calculators. And we end up getting about 35.685. So I didn't say what to round to. Let's go to the nearest whole number. So this gives us about 36 degrees. Okay, so we have 36 degrees here. So we can say that theta is equal to 36 degrees. All right. So again, why does this happen? Now, it happens because people much smarter than you or I, okay, they went through that painstaking process of looking at all the different types of ratios here in the blue, okay, and they measured by hand essentially all of these different angles associated with different side lengths. So not only is there a tangent table, there's also a sine table that looks like this. And we can see here that 7 divided by 12, okay, if I go 7 divided by 12, that gives me about 0.583 repeating, okay? So 0.583 recurring. And if I scroll down to my table here, so 0.583 recurring is going to match up very, very closely with this row right here, where 36 degrees corresponds to 0.5878. Okay. So fortunately for us, you don't have to do this anymore. Okay, this was used in the days before calculators were mainstream. These were found at the front and the back of maths textbooks. People had to kind of just go through and scroll down by finger to find out exactly what they were looking for based off of whatever ratio that was given to them. Okay, so I'm going to give you guys a few questions or a few different questions to work on. Okay, and we'll try those. Excuse me. We'll try those out and then we'll kind of see we'll see how we do and then yeah we'll kind of go whoops we'll kind of go from there. Okay, so I'm going to go ahead, move to back to my screen here, and then we'll pop these questions on the screen. What if it has two numbers multiplied together instead of dividing? So are you asking if we had something like, are you saying what happens if we have theta is equal to sine of or inverse sine of 7 times 3? That would never happen. We just wouldn't have that because remember our SOHCAHTOA, all of our ratios are always being divided. It's always opposite over hypotenuse, adjacent over hypotenuse, or opposite over adjacent. So we would never see two numbers being multiplied on the inside here because of the fact that our trig ratios are always one side divided by the other. Okay, so this would never ever happen. Okay, hopefully that answers your question. All right, perfect. So let's look at a few questions here. I'm going to put them up on the screen in just a second. And you guys take a minute or two to work these through. They're not going to take too long. And then we'll just kind of summarize that and then move on to, oops. And then we're going to move on to onto surface area and volume of spheres and cones. All right, so go ahead, find the unknown angle of these four. Let me know in the chat if you guys have any questions. I'll give you a minute or two to work these through on your own. Where did I get my calculator from? This is one I borrowed from the school. So there's a number that you guys can use. Typically, the one that most students I see using that's still pretty cost friendly are the Casio class whizzes. Those are about 25 pounds. I've seen anywhere from 20 to 30 pounds for those ones. So if you look for anything of the class whiz, that's pretty much what you want to look for. The one I have here, I think, is about 100+ pounds. So probably not one that you'd want to use if this is going to be your last maths exam ever. If you need to pick one up, 20 pounds, make sure you feel comfortable using it. Is the first one 68 degrees? The first one is 68 degrees. Yes, that's correct. Yeah, I'd advise that you guys find a calculator that you're comfortable using. Um, and the reason why I tell students not to use a phone calculator, so you see how we put sine, let's say sine 25, like this, and you can actually see me putting sine 25 first. On a phone calculator, you'd actually have to put 25 and then you hit sine. So that's why I really discourage you guys from using your phone calculators in class or at home. It just makes things a big mess, and it's not fun to try to undo that as a teacher. Okay, so don't use your phone calculator. The only exception that I would make to that is if you guys use an app. So, for example, I use an app called Taculator. Okay, so it looks kind of like this. Looks like this right here. Okay, so I'll type in what it looks like or what the actual name is. So Taculator just looks like that. It's a free graphing calculator app. Most of the functions that you guys are going to use at the GCSE level are free anyways. This looks just like the calculators we use in Canada. But yeah, it works just as well on your phone. But just don't use the iPhone calculator. The Android one's actually not bad, but the iPhone one makes me cry as a maths teacher. So please don't use it. All right. So just check through our answers. So we've got 68 for number seven, 68 degrees, 45, 38, and 36. Okay. So 68, 45, 38, and 36. So I'll go ahead and write those down just so you guys can get that as well. So 68, 45, oops, 68 degrees, 68 degrees, 45 degrees. And I said, what else did I say? 38 and 36. 38, 38, and 36 degrees. Okay. Are we feeling pretty good about that? Can you guys give me a thumbs up if we're ready to move on with cones? Yes, we've got a hand, or is that just a misclick? All right. So, if we're still having some issues, all right, can you guys make sure to come see me maybe sometime tomorrow? I'm more than happy to help you guys clear it up. I just want to make sure that I get through at least some of the spheres and cones before you. Some people have to leave just to be mindful of your time here. Okay. All right. So let's go ahead and start off with cones. And just kind of understand exactly where the formulas come from. Okay, so if I were to take the volume of a cylinder and compare it with the volume of a cone, all right, and let me go ahead and put a picture up here on the screen for you so we can kind of visualize what's happening. So we have some sort of cone, we have some sort of cylinder here. So hopefully you guys can tell this shape on the right is a cone, think of an ice cream cone. And the side here is on the left, a cylinder, think of like a soup can. If we were to have, okay, you guys take a look at our formula here. If we were to look at the formula, what do we notice is the only difference between these two? Anyone see the difference? So the only difference is just this one third here. Okay, so that one third, essentially, what that means is if I were to take two shapes, one being a cylinder and one being a cone, and they happen to have the same height and the same radius. Okay, so let's make a quick little sketch here. So we've got, let's say we've got a cylinder, it looks kind of like this, and this has a height of 10 and a radius, and let's call this radius here. This radius, let's say r is equal to 3. If we were to compare it with our cone that also has a radius of 3 and a height of 10, we would say that 3 cones fit into the cylinder, or rather 3 volumes, okay, or 3 cones worth of volume will fit into the cylinder. Okay, so I usually will do some sort of just demonstration where I'll take a cylinder and a cone of the same height, same radii or radius, and I will just fill it up with water. I'll pour 3 conefuls of water into the cylinder just to prove that it actually works out. Okay, so what I would actually recommend for you guys is when you guys are writing out this formula, because it's not given to you guys on the exam on your formula sheet. Okay, it's not given to you. Instead of writing it as one third, I would actually write it like this. I would write it like volume is equal to pi r squared h, and just divide the entire thing by 3. Okay. For whatever reason, lots of students like to type in one third in front, and that just causes a whole bunch of problems. So instead of multiplying by a third, you're just going to take whatever you have and divide it by 3. Trust me, just makes things a lot easier. All right. So moving into our first example, let's go ahead and work through a very quick example. Let's say we have something like this. Oh, I'm going to start off by making the pointy part. And let's do this. I'm going to draw this cone like this. And let's give this a radius. Let's call this radius is equal to 5 centimeters. And let's say that this height is equal to, let's say, 8 centimeters. Okay. So that height is equal to 8 centimeters. So we're going to start off with our formula first. So we have volume is equal to pi r squared h divided by 3. So we're trying to find the volume first. So we've identified our two variables that we need. And let's go ahead and put those into our formula here. So pi times 5 squared times 8. And maybe what I'll do is I'll color code this because I love color coding things when I'm teaching online. So pi times our radius squared. So pi times 5 squared times 8. And we're going to divide this all by 3. Okay. So if you'd like, you can put this all into your calculator. The only exception is if the exam says to express it in terms of pi. All right. So this is where just kind of understanding what's happening works really well. So we have 5 squared, which is going to be 25. And 25 times 8 gives me 200. Okay. So 25 times 8 gives me 200. We have 200 pi all divided by 3. Okay. So 200 pi divided by 3, this is what your answer would be um, if we asked to answer in terms of pi, because sometimes the exam will ask you to answer in terms of pi. So this is what you would leave it as. Okay. But if it says to answer to the nearest, I don't know, 10th, we'd actually have to put this into our calculators. So I can't do this in my head. 200 pi, let's go ahead, 200 pi, and we're going to divide that by 3. And let's go ahead and figure out what that decimal is. So I get 209.439. Okay, so if I said to the nearest 10th, so we'll say 209.4 centimeters, and it's got to be cubed, okay, because volume, okay, volume is in cubic units. So centimeters cubed, meters cubed, etc. Okay. So that's going to give you that accuracy mark. And this would be to 1 decimal place. Okay. And again, it's just depending on what the actual test is asking for in each case. All right. So for this one, happen to um, just choose 1 decimal place. Okay. I'm going to give you a slightly harder example here. This is really just kind of plug and play. Maths here is really not too bad. I expect most of you guys to do pretty well with this, aside from just having to memorize the formula. Okay. I'm going to give you a slightly adjusted version of this. And it's going to look like this. All right. So what I'm going to do is we're going to do this. I'm going to draw pretty much the exact same cone. You can't really draw cones any differently, which is kind of boring. Not at the GCSE level at least. I'm going to draw my cone looking like this. So I'm going to say that this guy here, so my radius, let's say radius is equal to 12 meters. And let's say that we aren't given this guy here. Okay, what I'm actually going to do is I'm going to tell you that this side right here is equal to, let's say, 17 meters. All right. And maybe I was being a little bit mean with how I drew this red line. So I'll do this, and maybe this will give you a hint if I draw it like this. Okay. So any ideas what we'd have to do in this case? What are we thinking of? What is that green? Why did I give you that green side instead? What makes this a harder question compared to the one that we just did? Any ideas? Let's hear from the chat. Let's hear from the audience. No takers. It's not the height. Perfect. It's not the height. Okay. So what we need to be careful of is the 17 meters is actually what we call the slant height. Okay. It's actually called the slant height. And what I'm going to do is I'm going to draw my actual height here. Let's do H. Okay, and you guys can hopefully see this triangle that I've just made with the blue, green, and red. So I've got blue and my green and my red, and this actually makes a nice triangle for us. And guess what we have to use to find the height? We're going to have to use Pythagoras theorem. Okay, so we're going to have to use Pythagoras theorem to help us figure out what h is. So for us, remember Pythagoras theorem was a squared plus b squared is equal to c squared being your hypotenuse squared. Okay, so let's go ahead and plug in our values. So we have 12 squared. It doesn't really matter which side is a or b. So 12 squared plus my b squared. So that's going to be plus h squared. And that will equal to 17 squared. So remember that c squared is going to be your hypotenuse squared. Okay. So let's go ahead and put this in. So we have 144 plus h squared. Oops. We have 144 plus h squared. And that will equal, excuse me, to 289. I'll do that in green. So that's equal to 289. Okay. And since we're trying to make h our subject, let's subtract 144 from both sides. So we get h squared is equal to 289 minus 144. That is 145. Okay. Where did I get 144 from? 12 squared is 12 times 12. So 12 times 12 gives us 144. Okay. So h squared is equal to 145. To make h the subject, to get rid of that square, I'm going to square root both sides. Okay, so square rooting both sides, I get the square root of 145. And here's a pro tip. Just leave it as the square root of 145. Unless you get a number like square root of 100, which gives you 10, then obviously use 10. But I'm going to use the square root of 145 because if I actually enter that into my calculator, square root of 145 gives us 12.04159,458, okay, which I don't want to write down, okay? So I'm just going to keep it as a square root of 145. How many marks would this kind of question be? I would guess that this would probably be at least 3 to 4 marks, okay, for this kind of question, just because of that extra, because of this extra step that we need to take coming into the question, okay? So roughly 3 to 4 is what I would guess, just depending on how nitpicky they want to be. All right, now that we have our height, let's go ahead, let's rewrite our formula here. So volume is equal to pi times r squared times h, all divided by 3. So volume is equal to pi times my radius squared, and maybe I'll do this in red. So pi times your radius squared and times my height. And I'm using brackets to multiply. So this topic is just surface area and volume of cones and spheres. All right, and from here, we just need to divide everything by 3. Okay, so if you want, you can put this all into your calculator at one time. Just make sure you're very, very careful with how you enter it. So I've got 144 times the square root of 145. And then I'm going to multiply the whole thing by pi. And then I'm going to divide everything by 3. So I will end up getting 1,815. It looks like I've got 0.829. I'll just say to the nearest 1 decimal place. And this is going to be, because I'm using meters, let me make some room for myself. This is going to be meters cubed. Okay, meters cubed. So meters cubed, and this is to 1 decimal place. Okay. Are you feeling okay about this type of question? All right. So what I'll get you guys to do is I won't I won't have time to go through more of these. I'm actually going to just put this picture up for you guys. Again, I'm going to post a link to this video recording along with the worksheets that I've used. Um, you guys want to do another one? Sure. Why not? Let's do it. Let's do another one then. Oops, not that picture. Let's go ahead and use the one that I just want to open. So let's do this one. So we'll take a look at these two or these four examples here. So you guys will see that sometimes you'll have more information than you need. So we're not worried about surface area right now. We're just worried about volume. So I'm working through the volume first. And then afterwards, we're going to run through surface area, which is harder than volume. Together. Okay, let's do one together. So these first three are pretty straightforward. What I would do is, let's say if we didn't know, let's say we didn't know that this was 24. Okay. Let's say we didn't know this was 24. So I'm just going to, um, actually, let's work with the first one. Why not? I'm going to scratch this out. Let's pretend we don't know what that is. Okay. So we have our cone here and we can make a triangle. So we know that this side here is going to be 10. This here is going to be 6, right? Because if I were to make the same triangle, right? 1, 2, and 3, right? Because they're symmetrical on either side. I've got a side length of 10, which is my hypotenuse, and this side length is going to be 6, which means that this side, the unknown side, let's call that h. So for us, we've got a squared plus b squared is equal to c squared. And we know that that c squared, again, is going to be our hypotenuse squared, which is, in this case, going to be 10 squared. So we have h squared plus 6 squared is equal to 10 squared. And we'll get h squared plus 36 is equal to 100. We can subtract 36 from both sides because we're trying to get the h squared by itself. So where did I get 36 and 100 from? 6 times 6 is 36, and 10 times 10 is 100. So I get h squared is equal to 64, and in this case, we get h is equal to the square root of 64, and we know that the square root of 64 is 8. Okay, and we already knew that because I ended up covering this up, which is fine. But if we didn't know what that was, okay, this would be the process to actually go through it. Okay, so let's go ahead and finish off this question. So once you get to this point, it's really not too bad. Okay, so you're asking why didn't I do b squared minus c squared? So I think you meant c squared minus b squared is equal to a squared, which would work as well. Okay. Again, it's really up to you with depending on whatever is more comfortable, right? So what tool is asked here is why am I not doing c squared minus, let's say, a squared is equal to b squared? That would work for sure. But again, I like to just go with the original Pythagoras theorem. I substitute first and then I'll make whatever my subject, right? Rather than having to remember what goes in front, what goes behind. Because even in the example that you gave me, you switched up the c squared and the b squared. It would be c squared minus b squared, right? So that's why I like to use a squared plus b squared is equal to c squared always to start off, and then you substitute. Hopefully that makes sense. It's not that you can't do what you've done, but in that case, you just have to go hypotenuse squared minus side squared is equal to unknown side squared, which would be fine. I hope that answered your question. No problem. All right. So once we get to this point, let's go and plug our or write down our formula again. So again, because this is not given to you, it's good to just commit this to memory. Pi r squared h, and that's all divided by 3. So we get volume is equal to pi times 6 squared. And because we have a nice whole number, times 8 divided by 3, it's going to look something like that. So we get 6 squared, which is 36, and 36 times 8 gives us 288. So we get 288 pi divided by 3. And again, this is our answer in terms of pi. In terms of pi. Okay, so if this is what the exam wants you to write, you just leave it like that. You don't put it. You don't need to put it as a decimal. All right, that's what they want you to have down. But if you ended up putting a decimal answer afterwards, yeah, just for the volume of a cone. So volume of a cone is equal to pi r squared h, and that's all divided by 3. All right. So if I go 288 pi and I divide that by 3, I think we ended up doing, I think this was the exact same, these are the exact same numbers that we had previously, which is fine. Just so happened that they all looked, that we got the same numbers or something very similar. We end up getting 288 pi over 3 gives us 301.6. This was, I think, centimeters cubed to 1 decimal place. Again, because I didn't really specify what it was going to be, I've just decided 1 decimal place because I'm the boss here. Okay. So hopefully that part makes sense with the cones. All right. At least for the volume of cones. All right. I'm going to move into the surface area of cones now, which arguably is much more difficult, okay, compared to the volume. Volume, really just have to memorize the formula. Same thing for the surface area though, although if you have troubles visualizing things, it can become pretty difficult for the surface area of a cone. All right. So again, if you have to leave, please feel free to do so. I'm going to continue to record this. Don't feel obligated to stay, but it would be nice if you guys hung out, just did some more maths with me for a little bit on this Tuesday night. I got nothing better to do than to do maths, right? That's really my life right now. So if you got to go, feel free to head out. I'll continue to teach here. But yes, if you got to go, thanks for hopping in. But if you're staying, still got a little bit more to go. All right. So when it comes to the surface area of a cone here, let's go ahead and excuse me. Let's go ahead and talk about what the surface area of a cone is going to be. So I'm going to actually put a picture here. So if we take a look at our net for a cone, where will you be able to access the recording of this session? So I'm going to post this up on, well, number one, first my YouTube channel, but then I'm also putting it on the foundations pages, and I'll send this out to your teachers as well. But if you look up me on YouTube, you guys will be able to find a copy of this recording later on. All right. Okay. So continuing on, for anyone who is sticking around and and just staying here, we're gonna talk about our surface area of a cone, which is going to be, again, arguably a little bit tougher. Okay, so for the surface area of a cone, we want to look at the 2 shapes that we have. So we can see here that we have that yellow portion, which we all know is a circle. And then we also have this curved area that's kind of looking like a pizza slice, really. The actual name of this shape kind of evades me right now. There's an actual name for this, but I can't remember. But this pink area is usually or sometimes referred to as the curved surface area or the lateral surface area of a cone. All right, so I'm gonna go ahead and write that down. So this is really just a circle on the bottom. So this is our circle, just a circle. And this is our curved surface area or lateral surface area, okay, for this cone. Okay, so in terms of actually putting this together, surface area we know is just the area that covers whatever shape we're looking at. Okay, so for the circle, you already know. You mean that area for this is equal to pi r squared, and then for this pink section, the area is equal to pi times r times L, and I'll write the L kind of like that. Okay, so pi times r times L. Okay, so I'll make a quick little note here that L is equal to our slant height. H is equal to what we call the perpendicular height. Right, and we call it the perpendicular height because this height is perpendicular to the ground. So all together, we can put this into one formula. Again, it is not given to you. The surface area of a cone is equal to pi r squared plus pi r times L. Okay, so basically we're just adding these two together to give us the surface area formula for a cone. So let's work through a few questions together, and then we'll see what we end up with. Okay. So let's start off with, let's see what we've got here. Let's go with this guy. So let me put this up on the screen. I'll put this up on the screen here, and we'll work through this first example. It's a bit bigger than I'd like. Getting old, but I don't need the cone to be that big. All right. So we've got this cone. It's got this measurement of 7 inches, and then the measurement here at the base of the cone is 2 inches. So you want to identify a few different things. We know that this 7 is actually our lateral, or sorry, our slant height in this case. So L is equal to 7 inches. And this 2, that is your radius. So radius is equal to 2 inches. Okay. So our surface area, and again, because we want to commit this to memory, let's go ahead and write that out. Pi r squared, which is the circle at the bottom, plus pi times r times L. Right. So we have R, we have L, we have everything that we need. So all we need to do is just to put these all into my formula. So SA is equal to pi times 2 squared plus pi times 2 times 7. Okay, so 2 squared gives me 4. So I'm going to have 4 pi. 2 times 7 over here is 14, so plus 14 pi. And again, if you get a question where they ask you for your answer in terms of pi, you can just go ahead and write 18 pi. So this is your answer in terms of pi. And if we actually put this into your calculator, 18 pi gives us 56.5. And again, I just like one decimal place, so we'll go 56.5. And this was what, inches? Inches squared to 1 decimal place. Okay, so 56.5 inches squared to 1 decimal place. And then remember, surface area is measured in square units. Square units, so centimeters squared, meters squared, inches squared, and so on. Okay. So that's the first type of question that you guys might see with surface area. Now, again, because we worked with the volume of cones and we could work with triangles, We could actually apply the same thing if they don't give you this slant height. So let's I'm just gonna draw a quick little example here. Let's say we have something that looks like this. Okay. And in this case, we're given, let's say, r is equal to 3 centimeters. We're given h is equal to 9 centimeters. And it's asking you to find the volume. Okay. So let's say we have that example. So I'll give you guys a second there to just draw a quick little sketch on your end. All right. So we can see here that we are missing our slant height. Okay. This L. Um, again, we use S actually in Canada. We say pi r s. So instead of pi r L, we use pi r s in Canada for slant height. But I can see why that gets really confusing. So use L here for lateral. So let's go ahead and figure out the volume of this. So we can see that we have another triangle. We've got the blue side, one blue side, and that is 9 centimeters. I'm just going to skip out on the units there. We have our hypotenuse, which is going to be L. And then we have this bottom side, which is 3. So from here, let's go ahead and write down my Pythagorean theorem. A squared plus b squared is equal to c squared. And because in this case, L is actually my hypotenuse, we don't need to worry too much about reconfiguring this. So now we have 9 squared plus 3 squared is equal to L squared. So this gives me 81 because 9 times 9 is 81 plus 3 squared. So that'll be plus 9 is equal to L squared. So we have 90 is equal to L squared. Okay. And we're going to square root both sides. So we get square root of 90 is equal to L. For those of you who have kind of tinkered around with surds, you'll know that you'll be able to simplify this to 3 root 10. If you have no idea what I just said, don't worry about it. Okay. For the foundation level. So we have L is just equal to the square root of 90. Okay. So L is equal to the square root of 90 because I don't want to work with decimals. And we're going to go ahead, rewrite our formula for a cone, or not the volume. We're looking at the surface area. Surface area of a cone is equal to pi r squared plus pi r L. Okay. From here, let's substitute our values. So we have pi times 3 squared plus pi times 3. Actually, that bugs me that I didn't put the bracket in red as well. Plus pi times 3 times my L, which was square root of 90. Okay. So this ends up giving us, we've got 9 pi plus, this is just 3 times root 90 times pi. So 3 times root 90 times pi. Again, if you don't want to write that out, not a big deal. I was doing that so I can make my calculation a little easier. So 9 pi plus 3 times root 90 and then times pi gives me a grand total of 117.7, and this is after rounding to one decimal place, centimeters squared, and this is to one decimal place. Okay. So hopefully that part makes sense. We've done the Pythagorean theorem or Pythagoras theorem for both the volume and the surface area of a cone here. Okay. Are you feeling okay about that sort of problem? Any questions about that? Okay, so if you're feeling okay, that's pretty awesome. Um, there's some other questions that might be a little harder than this. I'll post that up as extra practice, and if you guys have any questions, you can come see me in my classroom or ask your math teachers about it. But they'll just take up a little bit too much time. And this is really just an overview to get you guys thinking: are we feeling good about cones? Okay, so do you want to do your own? Yes, I can give you guys a chance to do your own here, and I'll post up the answers as well. So what I'll do actually is I'll just put that picture up again of the four questions that I had earlier. So these cones here. So I'll just kind of repaste that, and I'll get you to just take a picture of that. I'll get you to take a picture of it here and try that on your own, and then you can just go ahead and you can check your answers with the ones that I post online. Okay, and you can just check with your teacher as well. Just because I do want to touch on spheres really quickly before it's time for dinner. I had a bag of Doritos and a bowl of cereal as my dinner. I'm definitely gonna have to go and eat some more food after this. But I do want to touch on spheres very quickly before we're all done. So again, if you guys have to go, please don't feel obligated to stay. But I'll just continue teaching, even if it's just to like two or three people. Because what's more fun than doing maths on a Tuesday night, right? Nothing else is happening on a Tuesday night. Okay, not a problem. Take care if you're heading out. Okay, so let's talk about spheres here. So spheres, um, pretty straightforward. I would say that they're easier than cones for sure. Not a problem. Thank you guys. I think we'll probably still have a number of people left over. So let's talk about spheres. So basically, the volume of a sphere is just 4 pi r cubed over 3. Okay. And then the surface area of a sphere is equal to 4 pi r squared. All right, so hopefully that part makes sense there. So I'll give you a second there to copy that down. Again, these formulas or these formulae are not given to you guys on the formula sheet, so you do have to commit those to memory, unfortunately. Okay, so go ahead, take a second to write those down. All right. So let's talk about one other thing that you would need. So you'd also need the surface area of a hemisphere. Okay, so if we're thinking about the hemisphere here, there's a couple things that we can talk about. If we were to look at a hemisphere, which is just half a sphere. Okay, so full sphere is going to look like this. Let's see if I can draw one out. So it's going to look kind of like this. This is a full sphere here. Okay, these two formulae would apply for this shape here. All right. Now, if we were looking at a hemisphere, we'd really just be looking at this portion. Okay, so it's going to look like this. That just looks like a lemon slice. Actually, I'm going to redraw this a little bit. Again, I'm a maths teacher, not an art teacher, so feel free to judge. I think that just still looks like a lemon slice, but that's okay. That's fine. We'll survive with this. All right. So with this hemisphere, I might just end up just copying and pasting a picture from Google here. This is really distracting me. So I would find a picture from Google here. I want a nice pink hemisphere here. Let's do this. I give up. I can't draw. Let's get rid of this guy. I'm gonna paste a picture of a hemisphere. Okay. So there are two portions that we have to kind of be aware of. Okay. So for the surface area of a hemisphere, it's actually 3 pi r squared. Excuse me. And if we think about why it's 3 pi r squared, it can be a little bit confusing at first. Okay. So if we think about the surface area of a sphere, it's 4 pi r squared. Again, you guys don't have to worry about where the formula comes from. You just have to know what it is. We are basically saying that we have 4 circles. Okay, remember pi r squared is a circle, and we simply have 4 of them. If we cut a sphere in half, well, we're cutting this 4 in half, which gives us 2. Now the question is, where does that extra circle come from? Because we're saying that there's um, 3 circles in this case. Definition of surface area is really just the total area covering some sort of 3D shape. So surface area is for 3D shapes. Area is just for a 2D shape. All right. So the question is, where does that last circle come from? Okay, so imagine we cut this guy in half here. We're pretty much saying, okay, well, we've got this portion, right? This whole top portion is 2 pi r squared. But the part that we need to account for is if, for example, if you cut an orange in half, so you cut an orange in half, I wish we have some oranges somewhere. If you cut an orange in half, you get that flat part that you would see. So I'm holding up an orange like this, there's going to be a flat part. And if I hold it up to the camera, what shape would that be? It would be a flat circle. So you've got 2 circles that you're holding kind of curved in your hand like this. And that last side, that flat portion that you just cut through, is a third circle. So that's why the surface area formula for a hemisphere is 3 pi r squared and not 2 pi r squared. Okay. Does that hopefully make sense? All right. So if we're talking about the curved surface area, all right. So again, in questions, they might talk about the curved surface area. We can just say that the curved surface area is just 2 pi r squared, which is basically this blue section without the flat bottom. Okay. If you're having troubles visualizing that, I've got some pictures that I can probably show you as well, just to help you visualize things. But for now, just commit these to memory. 4 pi r squared is for a full sphere, 3 pi r squared for a hemisphere if we're um, including that kind of flattened out base. Okay. So the types of questions you might see for a sphere, you might see ones that are written out because volumes of spheres are pretty straightforward. I don't foresee anything too crazy coming up with the volume of a sphere. It's the last thing would be to just kind of work backwards, which I didn't quite get a chance to do. So I might do that here actually, just as an additional thing. So if we're looking at the volume of a sphere, let's say, for example, um, you're given a sphere. It looks like this. We got this, we got that. And let's do that. And let's say that your radius, let's say r is equal to 7 meters. Okay. So if we're looking at the volume, we've got volume is equal to 4 pi r cubed over 3. And some textbooks might write it out like this: 4 pi or 4/3 4 pi r cubed. Again, I don't like keeping the fraction in front. It just makes things a little bit confusing um, in terms of what you're doing in front. Don't make that harder than it needs to be. Okay. So hopefully that helps out. So I'll give you a second there to copy that down here. So, for the question here, Eva said, "What paper will this be in?" There's no restriction to which paper this can be in. It can be any part of it. It could be on a non-calculator portion. It could be on a calculator portion. Um, it could be on any of them, according to AQA. Thank you. Take care. If you're heading out. Okay. So let's work through this question. So if we have r is equal to 7, let's go ahead and substitute this into our formula. So 4 pi times 7 cubed And we're going to divide this by 3. So 4 pi r cubed, so 4 pi times 7 cubed. So 7 cubed is 343 times 4 is 1372. So we get 1372 pi over 3. And this is, again, our answer in terms of pi. And let's say if we weren't doing this in terms of pi, 1372 pi divided by 3, that would end up giving us 1436.8. And I said we were in meters. This would be meters cubed, rounded to the nearest 1 decimal place. Okay. All right. So there's really not much to it for this type of problem. The part where it becomes, where I can make it a little bit more difficult, is if I give you a sphere. So I'm going to give you a sphere, and I tell you, I say that volume. So if it's in the non-calculator portion, they would give you easier numbers to work with. So let's say they give you 4 pi times 2 cubed over 3. So this would be 8. This portion's 8 times 4, which is 32 pi over 3. And this would be meters cubed. And that's why you need to understand that sometimes they'll ask you for things in terms of pi. Hopefully that makes sense, right? Because you can definitely do 2 cubed times 4 over 3 and just leave it as a fraction in terms of pi. So that's the only way they'd be able to do it for a non-calculator. Otherwise, it'd be very unreasonable, in my opinion. Right? So let's say, for example, I tell you the volume is 120 centimeters cubed, and we're going to have to figure out the radius. So now we're going to have to work backwards. Okay? So let's try to work backwards and see what that radius is. All right? So starting with our formula, we have volume is equal to 4 pi r cubed divided by 3. And instead of substituting in radius, we're going to substitute in my volume. So volume is equal to 120. So 120 is equal to 4 pi r cubed over 3. So what we're trying to do now is to make r my subject. Okay. So first step is to multiply both sides by 3. So multiply by 3 on both sides. So these will reduce, and we'll get 360 on the left-hand side. 360 is equal to 4 pi r cubed. For this one, I would be really careful. I would advise for you guys, if you're unsure of why this needs to be done, right, just understand the rules of BEDMAS, BODMAS, BODMAS, PODMAS, PEDMAS, whatever you want to call it. Be careful with this. I would almost prefer for you guys just to do it like this. Because we're trying to make r the subject, I'm going to divide everything by 4 first. I'm going to divide by 4. So what I do to one side, I do to the other side. This will give me 90. 90 is equal to pi r cubed. And then I'm going to divide by pi. I'm going to divide by pi. And I'm actually just going to leave this as 90 divided by pi. And that will give me r cubed. And my last step is to take the cube root of both sides. So take the cube root of both sides, and that's equal to my radius. Okay, so I would go 90 divided by pi, and I'm going to take the cube root. So the cube root of 90 divided by pi. I'm going to be very careful with how I type this in. Cube root of 90 divided by pi, and I end up getting r is equal to 3.0598 ... And I'm just going to round this to 3. What did we have for units here? 3 centimeters. And this is I'll say this is one significant figure. Okay. Just to change things up a little bit. All right. So that's an example of how we can make a sphere question a little bit harder. All right. So this is why we got to be really careful typing this into our calculator. So what I feel like you might have done. So see how I've done this on my calculator here. You can see that I've got the cube root of 90 divided by pi all in the same bracket. I'm going to guess because you got 16.05. I feel like you probably did something like this: cube root of 90, and you divided by pi. Let's see if this. So some people might have gotten something like this. Okay, again, very different answers. You might have done this, or let's see what else you might have been able to do. 16.05. Not too sure how you got 16.05. You might have to show me tomorrow at school and I'll be able to get you sorted out there. But in terms of getting as many marks as possible, if you can get to this, you're looking pretty good, even if you get this last part wrong. But just make sure you're entering things into your calculator properly once you get to this stage. So you might have to come show me at school tomorrow. All right. Maybe one last example. Oh, you got it? Okay, perfect. Maybe one or two more examples, and then we are good to go. We're pushing 8:30 now, guys. You guys are a dedicated bunch. I really appreciate it. So, last couple, let's talk about examples with spheres here. But now we're talking about the surface area. Let's say we've got sphere. It looks like this: 1, 2, and I'm going to give my radius. In this case, let's say radius is equal. Say radius is equal to, what's the number I haven't used yet? Radius is equal to 5. Let's go 5 inches. So surface area is equal to 4 pi r squared. So we can go and substitute in 5 squared. 5 squared is 25, and 25 times 4 is 100 pi. So again, that could pop up in a non-calculator section as a pretty straightforward problem. We get 100 pi as our answer. So 100 pi gives us, we get 314.159, we'll say 0.1 inches squared, and this is to 1 decimal place. You guys can tell that I like going to 1 decimal place by default. Again, just make sure you're rounding according to what the question has asked you to do. Okay. So that's a very straightforward example. There's nothing really to that one. Again, the alternative is working backwards. Okay, working backwards. And I'm going to toss in a bit of a wrench for this one. Let's say, I'm going to type this question out. No, no, I'm not. I'm too lazy to type out the pi symbol. If the volume of a sphere, sorry, not volume, if the surface area of a sphere is, let's go with 150 pi, find its radius. And I'll say 150 pi centimeters squared, okay? Just to make your lives more difficult. And it really doesn't. It's just to be a bit more proper, okay? So 150 pi centimeters squared is the surface area. We need to be able to find the radius. All right. So again, like always, we want to make sure we start off with our formula. SA is equal to 4 pi r squared. All right. So SA is equal to 4 pi r squared. We are given the surface area, right? The surface area is simply 150 pi. So what I'm going to do is just simply substitute in that 150 pi on the left-hand side, and that's equal to 4 pi r squared. I can actually divide out pi on both sides, so I can just divide by pi, and I get rid of the pi's on both sides. And I get 150 is equal to, sorry, not 4 pi, is equal to just 4r squared. Let's divide both sides by 4. So I get 37.5 is equal to r squared. We'll square root both sides. So 30 square root of 37.5 is equal to r. And then we can go ahead, put that into our calculator. Square root of 37.5 gives us a grand total of, we get r is equal to 6.1 centimeters, and this is rounded to the nearest one decimal place. Okay, so it is quite common for them to make a question that a little bit harder just by saying their surface area or volume in terms of pi, right? So they'll give you 150 pi as your answer, and you're going to substitute that into or in for surface area or the volume, and you're just going to have to work backwards, okay, to make r your subject. Okay, so that's a variation that you very likely are going to see on the exam. All right. Do we have any questions? I feel like I've just talked a lot. I haven't really, unfortunately, given you guys a lot of time to work through these questions. What I'm going to do is just post a whole bunch of these. I'll send these out to your teachers to kind of post on Google Classroom as well. But these are ones that you guys can try on your own using the notes that I've given you guys. So let's go and where. Oh, here we go. I can give you guys this as an example. And you guys can use this to help you out. So I'll do this. Let's put these ones up. So give me a second here. And let's go with this guy here as well. So I'll put these both up. I've just taken these off the internet. So if you do need to find the answer key, just let me know. Send me an email. I can send those over to you if your teacher doesn't have them on hand. So I'll just shrink these down to size. You can take a picture of these, and then you can be off on your merry way. Oops, that is far too small. Let's do this. And here we go. Here's some extra practice for you guys to look for. Take a picture. And if you need the answer key, just send me an email. Or if you want to stick around, I can give you the answer key here. I'll just put it on the screen, actually. That way you can check it out on your own. So I took this from a website called Dr. Austin Maths. Fantastic website, just for some extra practice. Let me actually take a screenshot of all of this if I can. Here we go. And that way you can just go and use this. So really taking a picture of that. Get a picture of this. Oh, that's not what I wanted. Picture of the answers. Let's keep the resolution. And here we go. There you go. So you can take a picture of that as well, just to keep things simple, so you don't have to contact me about them. But if you do have any questions, feel free to let me know. Thank you guys so much for your attention tonight. I know it was a bit of a long session, so you guys are unused to doing maths for a full hour and a half. So I really appreciate the time that you guys have taken. Hopefully it's helped out. Thanks so much, and we'll see you guys next time. Take care.